Hello everyone, welcome to Medis Global. This is the fifth part of the mathematics in which we'll discuss about important formulas and short notes for the differential equations. Here these are the topics. First one is first order first degree differential equation. Second one is exact equation. Third one is linear differential equation for constant coefficients. Fourth one is Cauchy-Euler equation. Fifth one is Legendre's linear differential equation. Then the last topic is homogeneous linear equation with constant coefficients. So these are the outline of this lecture. Let's begin one by one. Here the first topic is differential equations. Here the first one is order of differential equation. It is the order of the highest derivative appearing in it. Then after degree of differential equation, it is the degree of the highest derivative occurring in it. After expressing the equation free from radicals and fractions as far as derivatives are concerned. Then third one is differential equation of first order first degree. Here equations of first order and first degree can be expressed in the form of f of x, y and y dash is equals to 0, or you can say that y dash is equals to f of x and y. Here following are the different ways of solving equations of first order and first degree. First one is variable separable. Here the equation is f of x into dx plus g of y into dy is equals to 0. For this type of question, here the solution is integration f of x dx plus integration g of y dy is equals to c, where c is equals to constant. Then after second one is homogeneous equation. Here the form of the equation will be dy by dx is equals to f of xy divided by g of xy. Here to solve a homogeneous equation, substitute y is equals to vx. Then dy by dx is equals to v plus x into dv by dx. Here separate the variable v and x and then after integrate. Then the next point is equations reducible to homogeneous equation. Here the differential equation is in the form of dy by dx is equals to ax plus by plus c divided by a dash x plus b dash y plus c dash. Here this is a non-homogeneous but can be converted into homogeneous equation. Case 1, if a by a dash is not equals to b by b dash, then substitute x is equals to capital X plus h and y is equals to capital Y plus k. Here h and k are constants. Then after solve for h and k, ah plus bk plus c is equals to 0. Then a dash h plus b dash k plus c dash equals to 0. So finally you will get this equation dy by dx is equals to ax plus by divided by a dash x plus b dash y. Then after in the case 2, if a by a dash is equals to b by b dash, then you have to use this term a by a dash is equals to b by b dash is equals to 1 by m. So after substituting this term 1 by m, you will get dy by dx is equals to ax plus by plus c divided by m into x plus by plus c dash. Then substitute ax plus by is equals to t, so that dt by dx is equals to b into t plus c divided by m into t plus c dash plus a. Then solve by variable separable method. So these are the two cases for non-homogeneous equation. Then after the next point is linear equations. Here the standard form of a linear equation of the first order can be written as dy by dx plus p of x into y is equals to q of x, where p and q are functions of x. Then after second order linear equation, here d square y dash divided by dx square plus p of x into dy by dx plus q of x into y is equals to r of x. Then commonly known as Leibniz's linear equation. Here integrating factor if is equals to e raised to integration p dx. Then the common general solution is y into e raised to p dx is equals to integration q into if dx plus c. So you can say that y into if is equals to integration q into if dx plus c. So this general solution is very useful in the examination, because every 1 or 2 years this question from linear equations were asked in the examination. So this is important Here note that the degree of every linear differential equation is always 1, but if the degree of the differential equation is 1, then it need not to be linear. Here the example is also given. Here the degree is 1, but it is not the linear equation. So keep this example in mind, and this note is also useful in the examination. Now let's move towards the next topic. Here as you can see that Bernoulli's equation. The equation is dy by dx plus p into y is equals to q into y raised to n, where p and q are functions of x only. Then divide by y raised to n. So we'll get this equation. Then substitute y raised to 1 minus n is equals to z. So dz by dx plus 1 minus n into pz is equals to q into 1 minus n. This is a linear equation and it can be solved easily. Then fourth one is exact differential equations. M of xy dx plus n of xy dy is equals to 0. This is the general form for the exact differential equations. Then the necessary and the sufficient condition for the differential equations m dx plus n dy is equals to 0 to be exact is del m by del y is equals to del n by del x. Then solution of exact differential equation integration y is equals to constant m dx plus integration terms of n not containing x into dy is equals to c. So this is also most favorite question for the examiner. Here these three equations, first one is linear, then after Bernoulli, and the third one is exact differential. From these three types, mostly one questions were asked in the examination. So keep these all three formulas in your mind. Now let's move towards the next one. Then after here the next topic is equation reducible to the exact equation. First one is integrating factor. Sometimes an equation which is not exact may become so on multiplication by some function known as integrating factor. Here some rules are there. First one is x dy plus y dx is equals to d of xy. Then after x dy minus y dx by x square is equals to d of y by x. Then similarly there are 4 more equations. You can note down this also. Number 3, x dy minus y dx divided by xy is equals to d log y by x. Then after x dy minus y dx by y square is equals to minus d of y by x. Then after fifth one is x dy minus y dx divided by x square plus y square is equals to d of tan inverse y by x. Then last one is x dy minus y dx divided by x square minus y square is equals to d into 1 by 2 log x plus y divided by x minus y. So here d for the differentiation as you all know. So these are some basic equations or forms you can remember. Now let's move towards the next one. Then after there are some more rules. Rule number 1, when m dx plus n dy is equals to 0 is homogeneous in x and y, and mx plus ny is not equals to 0, then if is equals to 1 upon mx plus ny. So these are the different conditions for which you have to use this equation of integrating factor. Here rule number 2, if the equation f1 of xy into y dx plus f2 of xy into x dx is equals to 0 and mx minus ny is not equals to 0, then if is equals to 1 upon mx minus ny. Then after if the m dx plus n dy is equals to 0 and 1 upon n into del m by del y minus del n by del x is equals to f of x, then integrating factor is equals to e raised to f of x dx. Then the last rule is if the equation m dx plus n dy is equals to 0 and 1 upon m del n by del x minus del m by del y is equals to f of y, then integrating factor is equals to e raised to integration f of y dy. So these are main 4 types of questions So for these different types you have to remember their integrating factor, because from one of the type the questions will be asked in your examination. So now let's move towards the next one. Here the next topic is linear differential equation with constant coefficients. So this is the representation for general equation of LD with constant coefficients. Then after, the equation can be written as d raised to n plus k1 d raised to n minus 1 plus up to kn into y is equals to x, where d is equals to d by dx. Here f of d into y is equals to x, where f of d is equals to 0 is called auxiliary equation. Then some rules for finding the complementary function. Here first rule is, or you can say that case 1, if all the roots of auxiliary equations are real and different, then you have to use this rule: d minus m1 into d minus m2 up to d minus mn into y is equals to 0. Here the solution is y is equals to c1 e raised to m1x plus c2 e raised to m2x plus up to cn e raised to mn x. So here this is the first case for which there are real and different roots. Now the next case is if two roots are equal. For example, m1 is equals to m2, then y is equals to c1 plus c2x into e raised to m1x. Similarly, if m1 is equals to m2 is equals to m3, then y is equals to c1 plus c2x plus c2x square into e raised to m1x. Then third case is if one pair of roots are imaginary. For example, m1 is equals to alpha plus I beta, then m2 is also equals to alpha minus I beta. Then here the solution will be y is equals to e raised to alpha x into c1 cos beta x plus c2 sin beta x. So yes, after calculating one example for each and every case, you will understand this equation and easily remember these equations. Then after, next case is if two pairs of root are imaginary, then for example repeated imaginary roots alpha plus or minus I beta and alpha plus or minus I beta, then y is equals to e raised to alpha x into c1x plus c2 cos beta x plus c3x plus c4 into sin beta x. So these are the four cases for linear differential equation with constant coefficients. Now let's move towards the next one. Here rules for finding the particular integral pi is equals to 1 upon d raised to n plus k1 d raised to n minus 1 plus up to kn into x is equals to 1 upon f of d into x. Here case 1, when x is equals to e raised to ax, then pi is equals to 1 upon f of d into e raised to ax. Here put d is equals to a, where f of a is not equals to 0. Similarly in the second one, pi is equals to x into 1 upon f dash d into e raised to ax. Put d is equals to a, then f dash a is not equals to 0 but f of a is equals to 0. Then pi is equals to x square 1 upon f double dash d into e raised to x. Then put d is equals to a. Here f of a is equals to 0, f dash a is equals to 0 and f double dash a is not equals to 0. Now the case 2, when x is equals to sin ax plus b or cos ax plus b, then pi is equals to 1 upon phi d square sin ax plus b. Here put d square is equals to minus a square, where phi of minus a square is not equals to 0. Then similarly pi is equals to x into 1 upon phi dash d square into sin x plus b. Put d square is equals to minus a square, where phi dash of minus a square is not equals to 0 and phi of minus a square is equals to 0. Then similarly the third case. So these are the two cases. Here some more cases are there. Let's see one by one. Here case number 3, when x is equals to x raised to m, where m being positive integer, then pi is equals to 1 upon f of d into x raised to m is equals to f of d inverse into x raised to m. So finally you will get this equation in the form of this one. Then after case 4, when x is equals to e raised to x into v, where v is function of x. Here pi is equals to 1 upon f of d into e raised to x into v. So pi is equals to e raised to ax into 1 upon f of d plus a into v. Then evaluate 1 upon f of dA into v as in case 1, 2 and 3. Then after here two more cases are there. Case number 5. Here as you can see that when capital X is equals to x into v of x, then pi is equals to 1 upon f of d into x into v of x is equals to x minus f dash d divided by f of d into 1 upon f of d into v of x. Then last case, when x is any other function of x, then pi is equals to 1 upon f of d into x. Then factorize f of d is equals to d minus m1, d minus m2 up to d minus mn, and resolve 1 upon f of d into partial fractions, and then apply 1 upon d minus a into x is equals to e raised to ax integration x into e raised to minus ax dx on each terms. Then the complete solution for all these 6 cases will be CF plus PI. Then here this is most favorite question for the examiner. From this topic there may be one question in every 1 or 2 year. So here the topic name is Cauchy-Euler equation, or you can say that homogeneous linear equation. Here this is the representation for this Cauchy-Euler equation. Then substitute x is equals to e raised to d, then after x into dy by dx is equals to dy, then x square into d square y by dx square is equals to d into d minus 1 into y, and x cube into d cube y by dx cube is equals to d into d minus 1 into d minus 2 into y. So after substituting these differentials, the Cauchy-Euler equation results into a linear equation with constant coefficients. Then it is very simple. As we have discussed earlier, in the 6 cases you have to choose any preferable case and you have to calculate this example according to the previous cases, so that cases are also useful in this Cauchy-Euler equation. Now let's move towards the next one. Here the next topic is Legender's linear equation. Here this is the representation for this Legender's linear equation. Then ax plus b is equals to e raised to t, and t is equals to ln ax plus b. So for this equation you have to substitute these values. Ax plus b into dy by dx is equals to a into dy, then x plus b square into d square y by dx square is equals to a square into d minus 1 into y, and third one is x plus b cube into d cube y by dx cube is equals to a cube into d minus 1 into d minus 2 into y. Then after substituting these differentials, the Legender's equation results into a linear equation with constant coefficients. So once again, that 6 cases are also useful for solving the examples of this Legender's linear equation. So in general, you must have to remember that 6 cases for linear differential equation with constant coefficients, which we have recently discussed. Now let's move towards the next one. Here this is most favorite MCQ for the examiner. Partial differential equations are used as mathematical models for phenomena in all branches of engineering and science. Here this is the general equation. So from this equation you have to remember this term b, a and c, then apply this condition. If b square minus 4ac is less than 0, then it is steady heat transfer, flow and diffusion. Here this equation you have to remember for the Laplace equations. Del square u by del x square plus del square u by del y square is equals to 0. Similarly for the parabolic, b square minus 4ac is equals to 0, and for the elliptical, b square minus 4ac less than 0. So these conditions you have to remember, because so many times questions were asked from these tables in the form of MCQ for 1 marks. Then this is the last topic of this lecture, homogeneous linear equation with constant coefficients. So this is the representation of the homogeneous linear equation with constant coefficients. This is called the homogeneous because all the terms containing derivative is of same order. Then here you have to substitute d is equals to del by del x and d dash is equals to del by del y. So your equation will be in the form of this one, d raised to n plus k1 d raised to n minus 1 into d dash plus up to kn d dash raised to n is equals to f of xy. So you can say that f of d and d dash is equals to f of xy. Then here there are some steps for finding the CF and PI. Here step number 1, write the auxiliary equation. So m raised to n plus k1 m raised to n minus 1 plus up to kn is equals to 0, where m is equals to d by d dash and the roots are m1, m2 up to mn. Then here two cases for finding the CF. First one is for distinct roots. CF is equals to f1 of y plus m1x plus f2 of y plus m2x up to infinite. Then CF is equals to f1 of y plus m1x plus x into f2 of y plus m1x plus f3 of y plus m3x plus up to infinite. Here two roots are equals. Then after step 2, finding the PI. PI is equals to 1 upon f of d and d dash into f of xy. Here four cases are there when f of ax plus by is equals to e raised to ax plus by, then put d is equals to a and d dash is equals to b. Then similarly for f of xy is equals to sin mx plus ny, then put d square is equals to minus m square, d into d dash is equals to minus mn and d dash square is equals to minus n square. Then third case, f of xy is equals to x raised to m into y raised to n. Pi is equals to 1 upon f of d and d dash into x raised to m into y raised to n, which is equals to f of d and d dash inverse into x raised to m into y raised to n. Then the last case is when f of xy is any function of x and y, then pi is equals to 1 upon f of d and d dash into f of xy. Then resolve 1 upon f of d and d dash into partial fraction considering f of d and d dash as the function of d alone, and operate each partial fraction on f of xy, remembering that 1 upon d minus m d dash into f of xy is equals to integration f of x and c minus mx dx, where c is replaced by y plus mx after integration. So basically these are some cases for which you have to remember the equations of CF and PI, and the general solution will be CF plus PI. So this is all about the fifth part of the mathematics, in which we have discussed about the important formulas and short notes for the differential equation. We have started from first order first degree differential equation, then after exact equation, then linear differential equation for constant coefficients, then after we have seen Cauchy-Euler equation, then Legendre's linear differential equation, and at the end homogeneous linear equation with constant coefficients. So we have covered all the important formulas from this portion. So if you like this video, please do like and subscribe for the upcoming videos. In the next video, we'll discuss about some important formulas for the complex variable, which is the final part of the complete mathematics, in which we have prepared total 6 parts. So the links for other 4 parts are given in the description box. Press the bell icon for the upcoming video. Share this video to the maximum study groups. Thank you so much. Hope for the best. Good luck.